get the screen out. Okay, you can see my screen. Okay, great. Thank you. I'm going to be talking about the enabling computationally intensive geospatial research on CyberGIS-Jupyter using CyberGIS-Compute. I guess it's a mouthful, but basically the talk is about CyberGIS-Compute and the platform that we have in order to support big kind of computationally intensive geospatial research. So getting some definitions out of the way. So what is CyberGIS? You can define CyberGIS as geospatial information science and system based on advanced cyber infrastructure. So combining GIS, traditional geospatial information science, with cyber infrastructure. So that's what we can define CyberGIS as. Jupyter, CyberGIS-Jupyter, you can think about it as a Jupyter hub environment. Many of you know Jupyter, maybe. It's kind of provides you an easy to use interface for going through your code and computation in a notebook kind of a fashion. So CyberGIS-Jupyter is essentially like a Jupyter hub environment that we provide with many of the CyberGIS and geospatial packages pre-built so that it's accessible to all the users. So why kind of CyberGIS for geospatial application? Because I guess, as I said, it provides easy to use interactive interface. So you could have a rich kind of a content-based output within the Jupyter environment. So you can do everything on your browser kind of things. But however, it has limited computational power, meaning so you cannot run, like if you have a model which takes a lot of computation, you cannot run it within the computer. So it is, you cannot run it within a browser. So it is kind of limited computing, but it is providing you easy access to this limited computing and to a broad audience. But if you want to do very computationally intensive things, you'll have to go beyond CyberGIS. So what about HPC, like high performance computing for geospatial application? Yes, that's kind of a tool, like many of you might be using such kind of systems, or some of you might be using it. You log in to using an SSH terminal and you figure out what to do in terms of the batch environment to submit your computational as tasks to the computer, to the system, and then get back the results. However, like there are various challenges. First of all, it's kind of many of the geospatial software and tools are not there, and you have to figure out your ways of installing them and configuring them to working within your user system. No interactive visualization, as well as the learning curve is extremely steep. So it kind of becomes very challenging for new users to use the system. So essentially, kind of we have a gap between these two systems, and what CyberGIS-Compute is situated is, and what's the motivation behind our CyberGIS-Compute development is to bridge this gap between the CyberGIS-Jupyter, which provides easy to access, and HPC, which provides like access to large computation, but maybe not that easy. So kind of bridging that gap so you can do scalable computation and data handling while keeping the advantage of like interactive computing environment and easy to use environment, which is offered by CyberGIS-Jupyter. So kind of saying that in a pictorial way, bridging between HPC and CyberGIS-Compute is, or CyberGIS-Jupyter is what the CyberGIS-Compute is aimed at. It has various kind of key components there that we have been developing. So we have a core, we have SDK, and we have a mechanism to do contribution. So core essentially is the middleware. And by middleware, I mean like it's kind of code that has already been written that knows how to talk to HPC system and manage the connection to the HPC system and does the handling of the computation. SDK is like the software development toolkit. This is mainly aimed at users so that you can even get like codeless interface UI access, or even like if you are a little bit advanced, you can get a little bit coding. So it provides you both like a API kind of an access as well as kind of a UI kind of an access that's built into our SDK, as well as we have the third thing is contribute, which is an important concept. Like so we want to allow new models, so for your computation to take use of the HPC. So that's where the contribute is situated. So you can have developer kind of facing APIs for you to allow model contribution with little or no modification to your existing code, so that it can run on these powerful computing environment. So this is a little bit more detail about our middleware server. It contains mainly 3 layers. You can think about it as an API server layer, which is the one which is talking to the SDK and provides the API and handles the connections from the user side of things. Then there is a maintainer pool and the connection pool. The maintainer pool basically is kind of per task, like say whenever the user is submitting something like a computation. So the maintainer essentially knows how to handle that computation, and the connection pool is essentially establishing the SSH connections, a pool of that to HPC, so that you can, like say, for example, like you establish a connection with the HPC, that's all handled in the backend, so we have a set of connections. So not every job establishes its own connection. We have a pool, and it reuses these pools in order to kind of minimize the load on the system and on the HPC side of things. So a little bit more detail. So on the compute API, it's kind of the user-facing RESTful interface. It provides also the authentication, so that we know who is actually submitting the job, and it pushes the job into a queue. The second one, I guess, the maintainer pool, it oversees the logic of the execution of any particular model, and talking to the HPC, and it connects to the HPC via the connector pool, which is kind of the next one. So HPC, SSH, long living connections, so that you can handle a large number of users at the same time, and it implements kind of mutex and those kinds of technologies to avoid race conditions. So this pool is allowed to share between multiple computational jobs. The SDK is mainly Python based. It basically integrates CyberGIS-Compute core functionalities into the CyberGIS-Jupyter environment and provides users seamless access. And it also provides like codeless access through an interactive UI. So it does both of those things. And lastly, the contribute is something like it allows you to contribute your own models and own computation to HPC. So how do we do that? We use like a GitHub, you basically submit a GitHub repository to be considered. If that GitHub repository will verify it, if it basically does what it's supposed to do, and it's kind of it doesn't contain any malware, we do some basic check, and also we have some configurations and manifest which needs to be written. We check those things, and if that's the case, we can allow you register your computation to take kind of use of the HPC. So we also tie it to a particular locket with a particular GitHub commit, so that like once it has been reviewed, it cannot be changed. So that's kind of more of a security measure. So kind of this is an holistic view of CyberGIS-Compute environment. So you can think about it as, and I did not touch everything here, but from an end user's point of view, you just talk through the SDK, through Jupyter, and then you use the compute core to talk to HPC, and then we also have like globals and other kinds of stuff integrated to do data transfer and things like that. And from a model contributor side, you just submit the codes to GitHub. And this model contributors, not everyone needs to be a model contributor. Only some people who need to, who want their computation to use the HPC, they can submit it as a model contributor, and then many others can use it. So like once you contribute a model, many users can use that model, and we'll see some examples. Quick links to this kind of the resources for this talk. I guess we have the CyberGIS, which is called the compute core, which is we call it as the job supervisor, which is there in the GitHub. So all those documentation are there along with the SDK and the Jupyter notebook. So that's the Jupyter notebook we'll be using in the tutorials. We have one other thing directly. So this is something we have put it on our own CyberGIS-X environment. Let me share that screen. But before I do that, any questions before I jump into the interactive, more of the interactive portion of it? Any questions you have? Oops. Okay. So hearing no questions, I'll move on. So this is the link for CyberGIS-Compute tutorial. You can find it in the, I guess we can post it in the chat as well. Becky, could you help me post this in the chat? So this will be an easy way for you to access the CyberGIS-Compute. So all you can do is click and open with CyberGIS-X. I am already registered. If you are not, it's a very simple registration process. Let me log out and show you. So you can register with CyberGIS-X within CI logon. And basically that means you can use your university credentials directly. So just say register with CyberGIS logon or CI logon, and then we have like a whole bunch of universities. So any of you who are part of the university system or the academic system, you should find your university potentially and be able to quickly sign up, and no other like checking is needed. Will allow you to directly log in. If you are using some like other accounts like Google or something, then there is an additional check. Someone has to manually approve. So I would highly recommend that you use your university credentials to log into that system. Let's see, go back and I say launch on CyberGIS-X. So that would open. So this will be kind of the notebook that it opens on CyberGIS-X. So it actually, so what happened there, what you saw was the CyberGIS-X hub environment, which is kind of the place where we put all our notebooks, and it's a place where community can find the notebooks. And essentially from there, you can just click a link and it launches onto CyberGIS Jupyter. So that's kind of our Jupyter environment, which is running on the back end. As I said, each of you will get your own instance, meaning within a compute, a core within the VM. So it's kind of a Docker instance, and where you will be running. And this is kind of CyberGIS-X. The access to CyberGIS-X is you will keep it even after, I guess, the conference and the workshop and the tutorial. So this is kind of an environment we are providing access to the community. So there are various examples in this notebook, and you can follow along with me along this example. So quickly about CyberGIS-Compute, we have these 4 examples that we have, and then I'll run through maybe a couple of them in this. So some quick prerequisite, of course, you have to know a little bit of programming, Python programming, familiarity with it, and some experience with Jupyter will be helpful, as well as GitHub repositories. So the first thing you'll have to do is install this guy. So you can run that. This, we are still working on integrating some of these things. This is kind of active research thing which is being demonstrated here. So after you do this, once you install this, it successfully installs, you will have to, I already have it, so which is why it's not installing, but you can restart your kernel. You'll have to restart your kernel once you do it, and that should be good. And after you restart your kernels, so that would make kind of the package that you currently installed immediately available to you. And this is kind of the client, the SDK package that we have. So from CyberGIS-Compute, we have this client which we are using. We are initializing an object here of CyberGIS-Compute, and then you see this list git is basically kind of you can think about it as showing all the computational models which are available right now. So there are some, of course, toy models with like Hello World kind of examples, but we also have some real models like the spatial accessibility model, spatial access, Fire ABM, which Becky has been leading. So those, like, we are increasingly starting to integrate many of the models, and you see kind of the Git instance that is associated with it. So you can go to the Git page and it's a particular commit which is getting associated with it. And that is the one which is getting pulled when you run on HPC. So now I'll quickly show you. This one is creating a job, a simple, like, so we used that object which we created, which is the CyberGIS-Compute object here. And now we are creating a job based on that object. Once you create that job, you can say what thing that you want to run. So in this case, we had a list of these compute. So in this case, I'll choose the hello world example, which is quite simple. And basically say, hi, I want to run this hello world example, and I want to pass it some parameters, I guess. So once I pass the parameter, I can do kind of the job.submit. And as you can see, it actually is running it on the backend. So it's going to run it on a computational node called Keeling, which is kind of our local computing system, but it's we have other things which have been integrated with some of the Exceed system. If any of you know those kinds of systems, some of the national supercomputing centers have cycles available for you that you can sign up for, and you can tie this computation with those kinds of cycles available as well. So I can quickly see the live output. So it's a very short job, so it will be quickly done. It shows you this is GMT, so kind of not in the future. Job is queued, it registered, and since it's a simple hello world job, it ended, and we can get the logs and the results out of it. So in this case, it's a very simple job which runs saying it's running setup, it's running main, and then it gives you all the environment which it was running along with the parameters that you passed, and the output there in this case. Any questions? I know this is kind of a lot of stuff kind of going through a little bit fast in a half an hour. So feel free to interrupt me if you have questions. Here's a second example where you can use, like, for example, in this case, we wanted to show you like the list of HPCs that are available. I mentioned Keeling. Expanse is one of the system. You see the URL that it's coming from San Diego Supercomputing, sdsc.edu, or it's Bridges, which is kind of in the Pittsburgh Supercomputing Center. So all those HPCs can be used for a particular model. Of course, not every model might be suited for every HPC. So you'll have to select the ones which is appropriate for that model. And we already showed you this kind of the models available. And when you run the model, there are kind of, we have 3 stages. So we have an initialization phase where you have this is all in Python. So from a user contribution point of view, you can say, hey, just run a setup.py, which does all your initialization step. Then you have your main execution phase, which can do, which could ideally do some parallel computing, distributed logic. So you could use multi-node, multi-core kind of computation and that goes into this execution stage, and the finalization stage or the cleanup stage is essentially run at the end of it. It's also usually runs single-threaded. So 1 and 3 are single-threaded. Stage 2 is generally a multi-threaded, multi-core, multi-node kind of an environment. And this is what, like, as a model contributor, you could do. You could specify, I guess, what is kind of in the manifest or JSON. When you go to one of these GitHub repositories, you will see. Let me take that as an example. Let's do a simple hello world. So you see the manifest.json file. This will be something which a developer submits, say what kind of thing is needed, pre-processing, post-processing, and then if you go there and you will see all your stages there setup.py, which is the setup stage. In this case, it's very simple. It's just printing. Main.py, it will be doing some other things associated with it. In this case, it's saying running main, and then it's doing a bunch of things in the hello world, which is what you saw in the output, right? So when I go back and you see the output here, when I ran the job, you saw a bunch of these things, and this is running main, and all those things came from it. So when I actually ran the job, it got the code from GitHub, it transferred it to the HPC, ran it, and gave me the result. So all those things are happening in the backend, and hidden from the user. So once kind of it's contributed, anyone can use it, just like I am using right now. Let's see. Yeah, this is, you could also do some status, and this notebook is available for you to play with. And of course, after this tutorial, if you have questions, feel free to reach out to me. Since we have such a short time, I don't want to go through it step by step. Let's see. This is the UI. So we also mentioned that we have a UI kind of thing built into SDK. So if you don't want to specify all those kinds of things, like if you see in the previous thing where I have to specify which GitHub was there, which is the executable folder, all those kinds of things might be a little bit more complicated for the user. So we are simplifying it further using a UI. You basically can select which GitHub repository you are interested in. Like, for example, you say hello world, and which endpoint you want to use, which HPC system you want to use. For more advanced users, you have all the Slurm options which are available to you. But for most people, you can leave this blank. And then if you have a bigger data sets and things like that, we have also integrated Globus file transfer. You can submit it, it does the computation, and you will see kind of the result. So it's kind of job is queued, it will be running, it will get executed. So this is a very short job, so it's boom, boom, done. So, and you see it's kind of the same job. What happened? So
that one failed because we didn't set the parameter. But
oh, did I miss?
So if you use the MPI hello world, that one.
Oh, sorry. Yep, I didn't set the parameter. So yeah. So I need to use the MPI hello world. I guess I need to run the cell again. So I guess, yep. So we submit the job, and yeah, so this worked, I guess. Since this is a multi-node environment, so we got that. So, and you see that I submitted it right now. We have a fourth example, which is on the evacuation model. I think this is a real model that you have. It's following kind of the same procedure, but if you see in this case, instead of the GitHub Dalo world, we are using the Fire ABM, which is something Becky created. So we could just do that. This model will take some time to execute, so we'll not be able to do this completely here, but you can just start it and you can submit the job, and it will take some time, I guess, to complete, and then you can download. So you could integrate it. So what I wanted to show is you could integrate it with the whole thing. I guess
actually this one goes pretty quick. So you can
I guess we changed the seeds to do it very quickly, right? So yeah, this is good. So I think it actually completed, which is great. And you see the results, and you can download the results into the results directory. And that would actually download it into your CyberGIS X environment, into the Jupyter environment, and then you could do some visualization and all those things after that. Okay. Anyway, I think it's still maybe doing the init phase. Yeah, it just finished. Right. So, yep, it did download the results. Uncap, do the extraction, and then display the result. In this case, this is creating a simple video. This is a fire evacuation model, a very small version of that model, I guess, just so that we could do a quick demo on it. So yeah, so you could integrate your whole workflow within the CyberGIS kind of X environment use the computation on the back end, the HPC, and continue your visualization here. I know I ran through this pretty quickly, and it's kind of it's quite dense, but I'm happy to take questions. And even after this call, if you have questions or if you're interested in this kind of capability, please reach out to me.
Great. So thank you for the talk. So maybe I will just ask a very quick question. I feel for many people here and also maybe outside the workshop, so they will be interested to know who can access the computing resources, and if they can access, then how much resource can they be allocated to, and also do you have GPU nodes available in CyberGIS as well?
Yeah, so I'll take, so first, anyone can access. So that's, anyone can access it. If you're using your academic credentials, it would be plainless and without any approval. If you're using like a Google or something, you will have to provide some abstract of what you want to do. And then it has to be a manual approval process. For the within the CyberGIS itself, you are provided a container. But when you do a submission to HPC, you have access to a lot more resources. Of course, like the model which gets submitted has to be vetted. As I said, you have a GitHub repository which you submit. And that is for security purpose. We don't want anyone to be running like a Bitcoin thing on HPC just because we are providing that access. So yeah, so there is, I would say there is a short, I would say maybe 500 to 1,000 SUs. Like that's kind of a how that's calculated. Maybe you can think about it as core hours is how much you will be generally provided, means access. You will be able to access these. So what we are doing in the backend is we are using community account on these HPCs, which is mainly a shared account, and we are able to do that. But if after that point, if you are still using it, then maybe we'll ask you to say, hey, you can go ahead and get your own allocation, and then we can tie your allocation and use your own allocation within the system. We have a little bit of GPU resources. That was your third question. Yeah, we have a little bit of GPU resources in-house, but most of our GPU resources are on Exceed, the supercomputing centers, and there we have some limited access to these.
Okay, great. Sounds great. Thank you for the answers. Yeah, so maybe many people here might be interested in trying out using the HPC resources that's freely available in there. Great.
Yep. Yeah, and if you're any of you are interested in contributing your model or anything like that for your own research, feel free to reach out.
Good.